Hello, everyone. This is College of Sequoia's College Algebra, spring 2020, COVID-19 lockdown. We're wrapping up the semester with some lecture notes on analytical geometry. This section is on hyperbolas. This is 10.3 in our textbook, hyperbolas. And they are similar to ellipses in shape or in equation. So ellipses, we had x squared over a squared plus y squared over b squared equaled 1. Or the x minus h and y minus k version, of course, when we change the center. Hyperbolas change by a single thing. One of these terms is negative. We have two choices. If our x term is positive, we have hyperbolas that open sideways. And it's both graphs, not just one. Both graphs curves. Alternatively, if the y squared term is positive, they open up and down. Okay. And what's so special about one of these? Well, hyperbolas are the set of all points in a plane where the absolute value of the difference of the distances between 2 points is constant. Those fixed points are called the foci. And notice its difference. That's for hyperbola. When we added them, the sum was led to ellipses. And let's just do the first problem, and I'll show you how to set them up, graph them, and do stuff like that. And then I'll illustrate what I'm talking about with those differences on our first graph. Okay. X squared over 4 minus y squared over 25 equals 1. This tells me a is the square root of the 1 underneath this. A equals 2, b equals 5. The first part is plot A and B distances from the center. So A equals 2, B equals 5. 2 left and right, 5 up and down. That's part 1. Part 2, make a box using those points. By generating more points. So what I mean by this is I'm going to do this. I'm going to make the lines go up and down. And sideways, and I'm going to make a box. And those are the points I was talking about. Generate those points. Connect the diagonals with dashed lines. These are asymptotes. They pass through the center. I think it's easier to start at the center of the box and draw the lines going outwards. So the way we have these right now, these asymptotes are y equals plus or minus b over ax. They're lines. Okay. Next thing we do is whichever letter is positive. Here, my x term is positive. This is telling me the graph opens left and right. I grab my vertex. This is a vertex. That's a vertex. And I literally Tron cycle towards the walls. We make our Tron cycle towards the asymptotes. Or in math lingo, approach them but never cross them. And here, my red lines are the hyperbola. Is that red line right there and that red line right there. Everything else is done to graph them. Remember we calculated C to go with foci? We're going to do that again. Right now, the foci are, the way it's set up, are going to be plus or minus C comma 0. In this case, it's H plus minus C comma K, but H and K are 0 here. C is a little different than before. It's not A squared minus B squared. It's A squared plus B squared. So in this problem, C squared is 4 plus 25 is 29. C is the square root of 29, which is about 5.4. Two, 3, 4, 5.4. That's a focus point. That's another focus point. These are the foci for, okay, let me show you what I meant by the distances again. or for first point. Now I'm going to redraw that, just sketching the hyperbola. So just as a sketch. And we had F1 over here and F2 over here. I'm going to call the distance from F1 to any point on the hyperbola, let's call that M. And the distance to F2 is N. And I could do any 2 points. I could go right here and call that N and call that M. Maybe I'll call this M2 and N2, M1 and N1. That whole distance thing was the absolute value of M1, or just M, minus N is a constant. Sometimes M is bigger than N, sometimes N is bigger than M, and that's why we use the absolute value. We subtract them, and that's what is constant here. Okay? So let's talk about our general rules for hyperbolas here. So the hyperbolas that open sideways, or the horizontal ones, the general form is x minus h squared over a squared minus y minus k squared over b squared equals 1. And I have this in Desmos, but I have not set up the equations for the asymptotes yet. So maybe I could type those in. Okay, let's see. Y minus k equals b divided by a times x, oops. Just putting in our general asymptotes real quick. I think this is the form when we've got h and k in. I'm going to make these both red and dotted. And let's see how that works. Let's do this one. Let me change that to be 5. That's 3. Yeah, it looks like I got them set up right. So here I'm doing the one where x is positive and they go sideways. The red lines are asymptotes. If I just have them go the opposite way where the y one's positive, now it opens up and down, and they still never cross the asymptotes. Okay? Maybe we should throw in the foci. H plus We'll make those all black, so they look a little bit like our asymptotes or our foci on the ellipses. And they can get quite a ways away. Okay. So hyperbolas, horizontal is like that. In both cases, c squared equals a squared plus b squared. Okay. The asymptotes are always going to be y minus k equals plus or minus b over a x minus h. Those are the asymptotes. That's true for both of them. This one has foci at h plus or minus c comma k. The vertices here are at h plus or minus a comma k. If we look at the other form, the vertical one, so this is the ones that open like that. They open up and down. Asymptotes are still in the same spot. These are easier to do by making the box. By the box rather than remembering the formula. In fact, I didn't remember these formulas that I just typed in. I've just gotten so used to moving equations from the center to HK that I knew this is what was going to happen when I did here. Here, the foci are at h comma k plus or minus c, and the vertices are at h k plus or minus b. This is when the y squared term is positive. This one is when the x squared term is positive. Okay. Eccentricity. For ellipses, it was E over the max of A and B. Not quite here. For hyperbolas, the horizontal one is E over A. The vertical one is C over A. And this one is C over B equals E. In general, it's E equals C over the positive one of A or B. Let's play around with quite a few of these. get some practice graphing them, see how this works. Notice how this HK thing hasn't really changed since we started working with it a long time ago at the start of the semester. It causes the entire graph to shift over HK. Or translate. So let's see, what's the first one we're going to do? Oh, that's a good one. Let's start with that one. 16y squared. Oops, just 16y squared minus 25x squared equals 400. Again, right side must equal 1. So we're going to divide by 400 to make that happen. 400 is conveniently 16 times 25. So 16 times 25, I'm going to replace them so I can cancel stuff out. On the y terms, I cancel out the 16s. And I get y squared over 25 minus, we cancel out the 25s, x squared over 16 equals 1. This gives me some information right away. Y squared is greater than 0. It's the positive term. Well, they're always greater than 0. I guess x squared is always greater than 0 too. But it's got a negative sign in front of it. This means this graph is opening up and down. A is always the one with x. B is always the one with y. I'm going to make my box. Hyperbolas are a little harder to draw because they always go outward. They're not like contained like the ellipse. There's my box. There's my A and my B. Okay. I will connect the diagonals with a dotted line, making my asymptotes. Y squared is the positive term. So we're going to open in the Y directions. We can find our foci. C squared is A squared plus B squared, which is 16 plus 25. C squared equals 41. C equals the square root of 41. Let's see, square root of 36 is 6, square root of 49 is 7. This is about 6.4. I'm estimating that. Maybe 6.3. 6.4, not bad. So I would go up to 6.4 and down to 6.4 from the center. And those are my focal points. My eccentricity here is C over the larger number. The larger number here is B. Square root of 41 over 5. Square root of 41 divided by 5 is approximately 1.28. Like I told you, for hyperbolas, it's greater than 1. Let's look at something interesting in Desmos real quick. And I want to, it's a kind of important. So we should talk about it. Let's move this back to the center. We don't need this shifted from the center to see it. Let's go 2 and 4. Oh, I've got c equals the square root of. That's not what c equals. C equals the square root of that. I'm like, why are those foci so far away? There we go. So the only ones that are really foci right now are the ones that are just inside of it. I want you to see what happens right now. It's opening up and down along B. When we make B and A about the same, it actually makes this giant X looking thing. It really does look like an X. When A increases, now those hyperbolas get really flat. You see that? Let's turn off the asymptotes for a second. The hyperbolas are getting really flat. Let's get it back down to 2. When B goes up, they get really narrow. Okay? Does it matter which graph I'm using? So if the way it's opening has the bigger number, it gets really flat. Right now it's opening in the X direction. I'm sorry, if the number with the X, the number with the positive number is small, it gets really flat like this when the other number is bigger. And when we switch the order of these, now B is small and gets really narrow. It's kind of neat how they're doing this. If you look at them both simultaneously, this is like having double sets of hyperbolas. Okay. Let's take a look at some more examples. My point there with showing you that it's hard to identify the shape just by looking at A and B. Where it was easy on an ellipse. A and B are not enough. Which direction they open also changes the shape. Okay. So let's do another problem. We're going to have x minus 2 squared over 16 minus y plus 4 squared equals 1. Find the center vertices, foci, domain, range, and let's go for the gusto, eccentricity as well. Okay, so where do I find the center? Let me pause and let you write that down. I gotta tell you, Pepsi Zero with wild cherry, good stuff. So my center comes from HK. And in this problem, it's 2, -4. What are A and B? A is the square root of the value under X is 4. B is the square root of the value under Y. When there is no value, there's a 1 under there, which makes the square root 1. C squared is A squared plus B squared, which is 17. So C equals the square root of 17, which is about 4.1, 4.2, something like that. Oh. How much did I have? I think I put that up afterwards. Yeah. I put Desmos up afterwards. Okay. So where I was going with this is it was hard to identify the shape just by looking at it. A and B, when it was easy as an ellipse, the direction changed here. So let me just pause. I realize you couldn't see the problem for the last 5 minutes. If we were in a classroom, someone could have told me what a jackass I'm being, but we're not. And I'm talking to a wall. It is not the most stimulating conversation. I'll tell you that right now. Okay. Hopefully you've paused it, wrote down the equation, worked out the center A, B, and C. Square root of 17 was 4.12, so I was pretty close. 4.1. Okay, so which way does this open? Up or down, left or right? The term in front, the positive 1, is x, which means it opens in the x directions. The arrows point along the same direction as x, which means C gets added to H and subtracted to H. The foci are at 2, and then we're going to add or subtract the square root of 17, and we still have K as -4. Vertices are H plus or minus A comma K, 2 plus or minus 4 comma -4. I've got one vertice at 6, -4. I've got another vertice at -2 comma -4. What else do I need here? I got my center, I got my vertices, I got my foci. Let's do eccentricity real quick here, and we'll do the graph and domain and range on the next page. Eccentricity is C over the positive 1. The positive 1 here is A. So E equals the square root of 17 over 4. It's about 1.03. And now let's graph what we got. I need to go to 2, -4, which means my center is in the 4th quadrant. And I need to go left and right 4. Up and down 1. So I'll make my box. Here, X is the positive term. We're opening to the left and the right. So we got a Tron cycle pretty quickly. Yes, Tron cycle is an official math term. You know how I know? I'm a math teacher and I use it. It must be true. What's the domain and range? Well, what is that point right there? That's my B1. B1 was -2, -4. I got these labeled backwards. B2 is 6, -4. Which means this is going all the way from -infinity up to -2. And then it stops, but it includes -2. And then it waits and it starts up again. And it goes from 6 to infinity. It looks kind of funny because it's making 2 different graphs, but the range is never not being touched. There's always a y value. The range is -infinity to infinity. Okay. Notice, let's point out something else. Notice E, which was approximately 1.03, is close to 1. And the graph is narrow. What happens when it's not? So let's put in the values we got into Desmos. Let me switch to Y, where it opens up and down. Here it's really wide. And this is, I got my eccentricity right next to it. C over B is 4.12. Let's go back and look at the other one, just so you're okay with it. What happens is A goes up. Oh, let's slow you way down. Here's my eccentricity. As A goes up, it's just getting closer and closer to 1, right? Let's move that back down. Let's make it like 2. Let's let B go up. And we're still opening left and right. We're still opening left and right. This is still my eccentricity because we're opening left and right. I need to slow that down too. So notice how E goes up. It's 1.5, 1.6. the graph, the blue line is getting really narrow or wide. It's widening out. Eccentricity is getting larger than 2. Is there a cutoff? Like what happens when they're the same? A and B are the same. So like neutral ground is when A and B are the same. It's about 1.414. What is that, the square root of 2? It is. So when E is the square root of 2, it's about pretty balanced. As soon as it starts getting a little bit larger, it starts to become less X-ish. It doesn't matter which ones I have in there. If they're equal, this value right here is the square root of 2. And it's because it's doing this right here. Okay. So narrow E is when it's close to 1. When E gets above E greater than about 1.5 or 2, the graph gets really wide. Or maybe flat is a good word to say. I mean, that's pretty flat. There's some curves still, but it's not much there. Okay, let's do another one, and then we'll work backwards. We'll find the equation given some information. Let me give you guys one to try. So we're going to work with y squared over 100 minus x squared over 81 equals 1. Find everything and graph. Okay, I'll assume you paused it. Which way is it opening? The y term is the one in front. It's the positive one. It's opening up and down. What's A and B? A is the square root of the 1 under x. Square root of 81 is 9. The square root of 100 is 10. C squared is 100 plus 81. So C is the square root of 181. Let's see, 169 is 13. 196 is 14, maybe 13.6. I always practice my math skills. 13.45, not quite 13.6. A little too much estimating. I didn't stop and think about which one it was closer to. So sketch it. Kind of sucks to sketch with that so big though, right? Let's say that's 9. And it should be a little bit bigger going up and down. That's 10. How's that? We'll skip putting the other things. It's opening up or down, which means if that's about 10, that's about the square root of 181. and it opens up and down. Oh, not from there, not from the focus. It's from the vertex. When you get a little too hasty, you start making mistakes, right? What's E? E is C over the bigger number, which means it's over B. Square root of 181 over 10. Where did I get that value? My old lecture notes are bad. Oh, I said over 10. Yeah, it's over 10. It's over the positive one. That's what's wrong with my old lecture notes. I put it over the wrong one. Oh, no, I got two sets of notes. There we go. Okay, so this is about 1.3. The domain here is infinite. The range here goes from negative infinity to 10, negative 10. And then it starts back up again at 10 and goes to infinity. Okay. A equals 9, B equals 10. HK is 0. What do we got here? 13.45. That's what we had here. 13.45 was our C. And if you have the asymptotes in there, you can see they never cross. All right, let's do one more type of problem. We're getting near the end of the material you're going to be tested on. So find the equation for the hyperbola. E equals 3, and we have foci at negative 2, 5, and negative 2, 3, negative 3. So it can't hurt to sketch something. Those are my foci, which means it's going to open up and down, right? Opens up and down. Where's the center? The center should be halfway between them, right? So how far apart is that? I've got a y value of 5 and a y value of negative 3. 5 minus negative 3 gets me the distance is 8. So this is 8 long, which means half of that is 4. We go down 4, 1, 2, 3, 4. That's my center. What does that tell me? Well, this gives me C, right? The distance between the center and the foci is C. And we just calculated that as 4. So we don't have A, we don't have B, we have C equals 4, we have E equals 3. We know it opens up and down, which tells us what? We should be looking at something with y minus k squared over b squared plus x minus h squared over a squared equals 1. We just found hk. What is that? If I go down 4 from negative 2, 5, subtract 4 from the y value, I get negative 2, 1. So that's my hk. Do I know anything else given the information I've got? I need something else to get A and B. Something's here that I have not looked at. Pause and think about it, see if you can figure it out. It's the eccentricity. What does E equal? E equals C over the positive value. The positive value here has to be B because it's opening up and down. We have 2 of those pieces of information. 3 equals 4 over C, or B. Which tells me B, if I cross multiply, I get a B over here, and then I divide by 3. B equals 4/3, which means B squared is 16 over 9. Okay, that helps somewhat. Can I find A? We can. C squared equals A squared plus B squared. C squared is 16. B squared is 16 over 9. So A squared equals 16 minus 16 over 9. We get a common denominator. That's 144 over 9 minus 16 over 9 is 128 over 9. That's all I need. I've got A squared. I've got B squared. I've got the equation. I've got the center is negative 2, 1. So let's just write it out on another page where we got a little bit more room. So let's rewrite our basic equation. And now let's plug in what we have. I've got K is 1. So I've got Y minus 1 squared over B squared is 16 over 9. Minus H is negative 2. So negative 2 is positive 2 over 128 over 9 equals 1. Now, we don't like that. We do not like having fractions within fractions. If I multiply this equation by 9 over 9 and this equation by 9 over 9, then one of these 9s will stay on top. The one on top will stay on top. But this 9 will cancel this 9. And that 9 will cancel that 9. And what we end up with is 9 times y minus 1 squared over 16 minus 9 times x plus 2 squared over 128 equals 1. Booyah. That's pretty much it for what you're going to be tested on. Tomorrow, I'm going to make a quick recap video on all the information for the conic sections because I think it's pretty handy to look at them all at once. So I'll make a short video on that tomorrow. And then I'm going to make videos for chapter 11 in case you didn't see the announcement with COVID-19 happening and everything not being able to go in person. I'm not going to test you on it. It's very, very important that you watch the material and maybe try to work through some of the problems, okay? You can, if you do it before the end of the semester, it's extra credit in Math Lab. If you do it afterwards, you're helping prepare yourself for calculus. You will need the stuff in chapter 11 for calculus. They will go over some of it again then, but it's helpful to have seen it before. So please, 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 even if you don't look at chapter 11 right now, at the end of the semester, watch these videos. You know where to find me on YouTube, Professor Hefe's channel. Come watch them, pause them, work through the problems, okay? It's been a pleasure teaching you. I'll make some more of those videos. I will make a video for what to expect on the final exam in the next couple of days so that you'll have something to expect, something to work off of. I think I'm going to make it in my math lab and just let you have 2 hours to do it. I'll go through and custom pick some problems and go from there. Okay? Peace.